So our first step will be understanding how images are represented digitally and how we can pull that information, how we can manipulate that information using Python. I don't know the background of all of you in terms of programming, but you don't need to know a lot about Python to understand these concepts. We're trying to keep them as simple as possible, but also we'll try to keep them in a way that you can use it. Okay, you will be able to apply the same knowledge. In Python, there are a couple of really important libraries for data science in general. One of them is Numpy, which is an array processing library. It will let you process arrays in a really efficient manner. Okay, so we're going to use this Numpy library along with map.lib. That what it does is just help us plot things in these Jupyter notebooks that we're using. I don't know if you guys have these Jupyter notebooks running locally. All right, that might be a little bit hard to get going. We're gonna actually release a guide on how to set up these notebooks locally in a couple of days. So hopefully you're gonna be benefited out of these. And at some point we wanna release these also as a service. So if that works, it might be good too. We will also use this Opencv library that it's actually a C library. I think it's C/C++. It has a bunch of code from C and C++. But there are bindings for Python, and this is a way more advanced library only intended for computer vision. Right? So it will let you manipulate your camera. It has algorithms already built in, optimizations algorithms. It's simple to parse images, to resize them, to, I don't know, convert them to grayscale, to change the channels of their colors. So you guys can do a ton of things. And actually, to be honest, we personally, we feel like we're always scratching the surface with these libraries. There are so many things that you can do, but it's really simple to get started. So to get started, in this case, what we have is how is a color represented, all right? Or what is color? Actually, color is of course a complicated physical concept, but digitally speaking, color in an image is going to be by a combination of three primary, we could say, they're not primary, but three main colors in this RGB model. There will be different models, right? Different standards to represent colors digitally. Different platforms might use different ones. Kind of a ubiquitous standard today is using the RGB one. So color is just a combination of three different variables. Pretty much all the colors that you can see in your screen are a combination, again, of a combination of red, green, and blue. Okay, and combining the intensity and the light of each one of these colors, you can, of course, access. I don't know. We have the count there, but of like 255. A really large set of numbers. There are different. There are other color modes. There are also, for example, we have also alpha channel, and there are a few things that are a little bit more complicated. But just to get started, again, if you think about color as a combination of red, green, and blue, right? It's enough to get us started. So here, for example, what you will be saying is any color. So you have, I don't know, think about your favorite color. It can be expressed as a combination, again, of red, green, and blue. And in this case, I'm just showing you how, for example, looks the red color. It just has this is bad. Actually, it should be 255 here and 0 here, and also blue is bad, but you guys get the idea. So again, from 0 to 255, you have to define the intensity of each one of the components of your final color. In this case, we have that red is 255. It's the maximum possible value, again, from 0 to 255. Green is 0, and B is 0. And actually, if you guys look at the source code of this notebook, what you will see is just simple HTML/CSS that you can actually tune to change the color you're using. So for example, let's see what happens if I add, I don't know, 120 here and 38. I'm just making it up. We're gonna see kind of an orange color because it has a ton of it has a ton of red, has a little bit of green, and it has some blue. So the final result is, again, this orange that we have right here. So again, many colors, not all of them, many colors, the ones we see that we kind of can see with our human eyes, can be represented with this combination of 0 to 255 of red, green, and blue. Right, so here we're showing you, a couple of examples. In this case, we have 25500 gives you this red color, 02550 gives you the green color, because the green channel, we can say, the green component is at the top, it's at the maximum value, and both red and blue are 0. And finally, blue in this case is also at the maximum, so that's why we have a blue here. And just again to try it out, I draw gray here. You guys can again change this thing. We can add a little bit more green, and we can add a little bit more blue, and we're gonna drop the red channel. We're gonna see, there you go. There's another color we get, and actually this too green, so we can change it. And again, you can generate a bunch of colors just by the combination of these 3 components. And this is going to be kind of the objective or the way to generate more colors, right? You are tuning these 3 knobs, right? You have, and you will be creating different colors. If you move if you increase the number of red and you increase the number of blue, you get to this point, right? If you increase the number of green, you get to this point. So it's again like this cube that you're creating for each color by tuning those knobs. What is an image now? An image, it's just, and you probably know it, if you've ever seen a pixelated picture on the internet, you know, you say it needs more JPEG, right? Classical meme. It's an image, it's just a bunch of different pixels that represent colors. Okay, so even the camera with the highest quality ever, it's gonna be just a bunch of pixels, it's a digital image. It's going to be a bunch of pixels representing color in each one of them. So in this case, this image, right here, it has white, it has a kind of brown or a dark yellow, it has white here, it has a lighted yellow right here. So by combining these colors, we get the final values represented in this image. So how are you going to represent these images using Python? We're just going to represent them as a matrix of x pixels high by y pixels wide, or actually the opposite, right? X pixels wide and x pixels wide and y pixels high, right? That's going to be our image. And each one of those points, it's going to be a color pixel. But as we saw, each one of these color pixels is represented by 3 values. So these pixels that I have right here, for example, the first pixel of the blue drop, it's going to be the pixel in position, I don't know, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, I don't know, 6, 7, 10, 12, right? It's going to be 5, 12, and that pixel by itself has 3 different colors. So we're going to use kind of a matrix. This, if you guys are getting started with programming, it might be challenging. It's how you represent the kind of matrices or nested lists within Python. But in this case, you can think that you have a matrix, right? Let me just show it to you. There you go. It's a simple image that it has 2 pixels by 2 pixels. That's it. And each one of these, of course, is a pixel. And actually, if I show you the colors, there you go. So this is when you turn this 2D image, it's just 2 dimensions, into kind of a 3D image, right? Because you have each pixel, right, each pixel is by itself, it's not a flat structure, it's by itself, it's another vector, right? So that's when you have, in this case, 2 rows by 2 columns, right here, 2 columns, but itself, each one of these columns is represented as another vector. Okay, so from the simplest image, that it's this one probably, right, just a 2 by 2 image, to something like a full HD, I don't know, what's the best mobile phone out there, the one that is taking the best possible pictures in the market today, that it's going to be like 12 megapixels or 24 megapixels. I don't know too much about it. That's going to be just, again, a combination of these same principles. It's going to be matrix with colors represented inside. So you guys can try with these notebooks later. We're generating here random colors. I can generate a matrix that it's a little bit bigger, right, in that case. So we have 10 pixels by 10 pixels. And again, the largest image you can think of, like, I don't know, full HD, for example, or 4K, it's going to be just this thing with a ton more pixels, but it's basically this thing. So what we will be doing now is start working with this Opencv library, and I'm going to show you a couple of things we can do. The first thing is that we're going to use an image here that I actually have it. Where is it? You guys can see my file browser, right? This one? Can you see Chewy here? Yes? Okay, I can hear anybody, but it's fine. This one, right? It's going to be read. I just read the Chuaka image, and it was read as a simple NumPy array. And actually, it's a NumPy array of, and I can show you guys here the information of this. Well, in this case, it's a little bit larger. I think we're, oh no, it's fine. 700 pixels by 393 and 3 dimensions, because these is going to be the color. This is going to be the interesting thing. Each pixel is represented by, again, 3 different components. And now I can show you this image, the one that I have just imported. But what you will see right here, and different from this image that I had, is that it's kind of inverted, right? And it's actually because by default, the Opencv library, it's not using the RGB model. Remember, RGB, red, green, blue. It's actually using the BGR, which is blue, green, red, right? So it's a different model. It's by default, it's importing a different model. It's pretty simple to change that, of course. In that case, you just need to turn your image. You can transform the color, and you can say BGR to RGB, period. You show the image, and it's done. If you need other types of transformations, and these might be at some point common, depending of the machine learning task you need and the pre-processing of the images that you need. Sometimes with machine learning, color is not that important, so you can kind of get rid of those components. It depends. In this case, you turn it into a grayscale. It's extremely simple. Resizing it, it's also going to be simple. I'm just going to show the examples as quickly as possible, because I want to get into the first machine learning model. In this case, the resizing was kind of fixed, right? It wasn't dynamic. The image is 700 pixels by 300 pixels, or 350 or something. I just resized it to a different proportion, right? I'm not keeping the same aspect ratio. I'm just, hard coding 300 by 300, and of course that the image is I don't know, now it's deformed, right? That's not holding the same aspect ratio as before. So when you're rescaling or resizing images, sometimes it's important to keep that aspect ratio. For colors or simple objects, not that important, but if you're basing your machine learning model in the shape of something, for example, the shape of a face, then it's going to be important to keep a good aspect ratio, or actually to keep the aspect ratio of your image, okay? Cropping is also pretty simple. What you will try to do is kind of find the center of the image and crop from there, pretty much. And finally, we're showing you a little bit extra detail. This is not going to be really useful for machine learning, but so you can see how simple it is to work with the Opencv library. And now we're going to get to the to the first machine learning model of the night, which is the color detection model. All right, so we're going to take an image and we're going to detect the dominant color. We say we're going to try to extract 5 colors out of the image. So to get started, I'm going to load the sklearn library. It's a really good library for machine learning, especially for education. So when you're just getting started, the sklearn library rocks. And we are going to use the k-means algorithm. It's a non-supervised machine learning algorithm. I don't know if you have this background, but in machine learning, you have supervised, you have unsupervised, and you have something in between that it's reinforcement learning. In this case, k-means is unsupervised, okay? And what k-means is going to do is you're going to give it a bunch of data, and it will try identifying groups by itself without you expressing anything about that data. The best possible example is a recommendation system. So for example, Netflix or Spotify. Netflix or Spotify, for example, has 1 million users, more than 1 million, but has a ton of users. And what it wants to do is kind of group those users by similar interests, right? Trying to find matches in terms of what the user likes so they can recommend things to each other. The way it's going to do that, Spotify is not going to analyze each user manually. Let's going to say, I don't know, this person likes this artist, and we're going to put it in this table, the rock table, and this other person likes blues, so we're going to put him in the blues bucket, because that would require a ton of human work. You have to see the artists that they like, and you have to classify those users manually, saying this person is listening to B.B. King all day, we're going to put it in the blues bucket, and these guys are listening to Led Zeppelin all day, so we're going to put it in the rock bucket, right? That's going to take a lot of manual work. So the unsupervised learning mechanism, what it's going to do is you're going to just throw the users to the model, and the model is going to figure out different groups out of that data. So it might, for example, it's going to group me and someone else in the same group, and it's not going to make any judgment. It's not going to say, I grouped these guys because these two guys like blues. No, it's just going to say, hey, these two users are really similar. They're in the same cluster. That's it. You can, of course, then do a little bit of analysis and say, okay, let's actually see what these users have in common. But the unsupervised learning method is going to work by itself. It's just going to find those groups by itself. So let's get started here. I'm loading sklearn. I have a utility function that it's the RGB to hexadecimal. As you guys know, you can represent RGB to X. If you've ever worked with CSS of HTML, you know it already. And we're actually we're gonna define this machine learning model, which is extremely simple. The first thing we're gonna do is load the image. With that image, we're gonna, as usual, transform. Remember that Opencv is loading it as BGR. We're gonna turn it into RGB. From then, we're gonna resize it, and this is a really important step. Remember that a picture or an image was this matrix of X pixels wide by Y pixels height times 3 for each one of the pixels colors. So if you guys don't resize your images when working with your machine learning models, it's going to take a lot of time to train, all right? If you have a ton of processing power, you might decide not to resize them. That's great, because you are not losing any sort of information. But in this case, we are actually resizing them. Once we've resized and pretty much everything right here, everything here is done, what I'm going to do is create a k-means scikit-learn model. And this is pretty fun, because out of these, let me just show it to you. I'm going to run it again. We have the images kind of preloaded, right? So you guys can load these notebooks and run the examples. It might find different results, by the way. Let's see if it does. So if you keep an eye on one of these colors, it's going to find a different result. Well, in this case, it didn't. There you go. So it has a different result, because the clusters are created, or they are initialized randomly. Okay, so you might find, you will actually find different, probably you will find different results. So the machine learning model, the one that it's extracting the colors out of this picture, is pretty simple, and it's only these two lines right here: creating the model and putting the and fitting and predicting. It's kind of a combined method. And in our machine learning classes, actually, we have a notebook in which we run our students through a bunch of machine learning methods, and they are all as simple as you see right here. It's creating the model with a given parameter. It's important to define how many, in this case, clusters we want, and then you're fitting it. When you fit it, you create the labels, you kind of extract those labels, and then we show this pie chart right here. So here what I could do is tune the K parameter. So instead of finding 6 different clusters, I might want to find, for example, 3 and see what it has. There you go. So these 3 are the clusters that it found. And here we can try K equals 3, 2. There you go. So this was the first machine learning model applied to images. And as you guys see, it's extremely simple. The machine learning model, sorry if I'm disappointing someone, just 2 lines, literally, and you have it working. This is actually, sorry, I have someone with a little bit of background noise. Ryan, can you mute your mic? Thank you. You can, of course, unmute it if you have any questions. Ryan, Tom, can you guys keep an eye on if you see questions, just in case? And let me know if there are. So, guys, as I was saying, the machine learning model is extremely simple. The power, the magic happens especially in the image processing part. Okay, reading the image, transforming it, resizing it, etc. Okay, everything else is fairly simple. We actually came up with this model by working with a friend company. They needed to classify clothes based on color, right? So when you're shopping, right, you can let your users filter something like greens or reds, or I want a blue shirt, right? You could manually tag each piece of clothing manually, or you can train a simple machine learning model. It's going to work for you. So we are now going to use the Opencv camera. Here, oh, sorry. There you go. So I want to go as quickly as possible. Actually, you know what, guys? I'm going to skip over this. You can see it later. Here you actually have a couple of examples. I don't want to waste your time with this because this is more Opencv, where I want to just go to the machine learning model and show it to you in action, because that's a lot of fun. But basically, this Opencv model, actually I could run it. Let me see. No need. What it's going to do, it's going to spin a new component in your machine that is going to turn your webcam, and it will let you capture video out of it. We're actually selecting the camera right here. If you have more cameras, you can change this integer to select other ones. And in this case, it's going to let you capture video out of your camera. It's also going to let you, for example, crop and resize images all live, kind of, as you are having the panel or the component exposed. All right, so just look it up by yourselves. It's just a quick tutorial of how to use Opencv. We're gonna jump directly to something a little bit more interesting, okay? Because again, it's so well, this is pretty much the same thing. More camera. Again, now that we've created this for you, it's gonna be a lot easier. Okay, so this is usually, it does require a little bit of work to get it running. So you can use this notebook, the number 4, to generate objects photographs or pictures out of your objects on your own. So we're gonna skip directly to our first deep neural network of the night. That it's gonna take me, how much time do you guys think? Actually, I'm gonna tell you what it does. And I think I can just spin it. Yes, this thing is working. So I'm gonna get this thing running. Let me see when it starts. Thing. There you go. There you go. So this is the Opencv camera. Can you guys see this?
Yep.
Thank you. So It seems like I'm a chihuahua. I don't know how fast you guys can get the updates of the camera, but I'm gonna start approaching with objects, and we're gonna see what it says. Okay, so I'm gonna approach with the scissors, with a pair of scissors. I haven't tried scissors, so I don't know if it has it actually trained. Let's see. Not working. Letter opener. No, it probably doesn't have a scissor. Let's try with a ballpoint or with a pen. Let's see if it has it. Phone and pens, ballpoint, phone and pen. There you go, phone and pen. It's pretty good. I mean, the models are, of course, are not perfect, especially with the way I'm running them, but it works. Let's see if I have here, I don't know, the remote of our AC. Let's say what it says. I don't know if it has a remote control. There you go. Can you guys see it? Remote control. Pretty cool, right? It's giving us the probability of having that object. In that case, given the resizing that we're doing of images to have this workshop running live and to be simple, the probabilities, as you can see, are pretty low. But again, the class with the highest probability is the correct one. It's a remote control. Let's see my water. Let's see what it says about my water bottle. Water bottle, there you go. See, 76% water bottle, it's working. So what about my phone? I'm just getting excited about it. I'm gonna spend the whole night looking at pictures, to be honest. There you go, iPod, cellular phone, perfume, no. See, it actually has iPod classes, pretty fun. So again, I could keep trying on objects. Let's see a cup. I haven't tried this one. Pitcher, coffee mug, yes. There you go. So as you can see, this thing is working. By the way, when you run this camera, look at the comments we provided. So for example, to quit the camera, you just need to press the Q key. That's it. It's gonna quit. So how is this thing going to work now that you guys saw it in action? This model, or this machine learning model, is actually, we're gonna look for ImageNet right here, is a neural network, a deep neural network that was trained by Google. You guys can Google Inception v3. It's a neural network that is already created by Google, and it's pre-trained with the ImageNet dataset. And what is ImageNet? It's a huge data set of images that it's part of a year competition. You know, in this case, it has 14 million different images. And I think these are the, no, I don't know where are the classes. I think there are 1,000 different classes. So once per year, the best colleges out there, the best, I don't know, research groups, they get together to beat the ImageNet challenge. And the idea is who is getting the best possible accuracy score at predicting images. So this happens once per year. And most of these groups, once they are done with the competition, they are releasing their models as open source models. And in this case, we can just import it with a simple Python import. So in this case, what I'm doing is I'm doing from Keras application import Inception v3. Keras has these. I should have linked you guys to the documentation here. Keras is, I'm sorry, I'm always skipping kind of the introductions. I don't want to bore you with the details. Keras is a really simple API or library on top of TensorFlow and a few other actually libraries. And what Keras does is it gives you a really simple interface to manage, to create neural networks. And it has already some models already created. So all these ones are already created. And these are usually from that ImageNet competition, some of them at least. Inception v3 is the one we're currently using, right? And you can tune the arguments, you can change the weights. So there are different actually weights or kind of pre-trained weights that you can get. Another pretty common one is this VGG16, that it was also from an ImageNet competition. It was also released as open source. I think MobileNet too. MobileNet is a really popular one because it's supposedly to be low power. I haven't tried it by myself, but it's low power, so it's one model you can fit, you can use in a mobile phone, for example. So you can use a machine learning model in your phone, and it's supposedly gonna run better. So all these are already pre-trained, not just pre-trained, but pre-created neural networks by itself. So the whole model, the layers, the pooling, the dense layers, the everything is already done, and it's already configured, and it's created for these neural networks. So you can do just from Keras import applications import Inception v3, and as you can do Inception v3, you can import VGG16 or MobileNet or any other one, and get it going with these weights, and you have it again, as we've seen, classifying and predicting images live. Okay, so in this case, I am pulling a cell phone image. This one was taken here in this office, and it's actually Matthias' phone. And as you can see, it has a pretty good accuracy score for cellular phone. Let's see what we have. What else we have here? Chewy. No, Chewy, it's not going to recognize you. This one, we're going to try the birds. I probably need to resize it. I'm going to use data/1.jpg. There you go, it's working. Let's see what it says. It's 1. Yeah. There you go. Bee eater, Indian bunking. All right, it's doing its best, right? So these images are not probably the best possible ones. Again, we're using the models already. We're using not just the model created by these guys, we're also using the weights that they were trained with for these type of objects. So here in this ImageNet library, you have a limited set of 1,000 different objects. So if, I don't know, if, as I was using scissors today, if there are no scissors in these data set, it's impossible for it to recognize it, to be honest. Any questions? Can you guys see any questions out there? Anything we should stop and take a look at? Actually, I can see right here. Oh, there we go. We're good. We're doing good. All right. So now we're actually going to the strong point of the night, which is our own neural network. Okay, we have created this model. We have trained this model with our own pictures, all right? And we're gonna make it classify and predict things live, okay? So again, this is all homebrew, all right? This is all homebrew. So a few things. This model, let's actually get started with these things right here. I will not re-execute this notebook because it actually will do it. We have time. Yeah, you guys will see the model being trained live. Okay? So what we're going to do with this simple model is we will be loading the camera and taking pictures of things that we wanted to classify. So when you load this same notebook, I'm going to run the camera. Okay? And where is the execution of it? There you go. And what you guys will do is get close with your objects, and you're going to start pressing the key in your keyboard, the number 1, the number 2, the number 3, the number 4, right? We're actually capturing those events here, 1, 2, 3, 4, and it's going to save it as different types of images or different classes. Oh, sorry. There you go. So you're going to save these 4 classes. Again, we created 4 because it was demonstration purposes. You guys can create more if you want. So it's going to create these 4 different classes, and it's going to store them all in your local directory. So right here in data, I have, for example, image type 1. Here, what we defined was banana was 1, red apple was 2, here was 3, and green apple is 4. So here I have my banana pictures, right? I try to move it forward and backward and spin it a little bit, so trying to different shapes, or because this is going to be the data that's going to be used for the machine learning model, right, for the neural net. So more pictures right here of an apple. And as you can see, the pictures are not perfect. They're kind of pixelated. My hand is there. Sometimes my shoulder is there. So it's not perfect. It's going to work. And again, it's going to keep here. So it's going to, again, keep different pictures in different directories. And what we're going to do is we're going to load those images right here from those directories. In this case, what we're using is the pre-processing model of Keras. Okay, so Keras, that machine learning framework that I showed you before, it also includes a couple of utility libraries. Sorry, in this case, is the pre-processing module that's going to load images from the directory you're specifying, and we're also turning them into arrays, as you guys remember. So let me show you the bananas right here. There you go. Enumerate type 1 at 0. This is my first banana picture. So this one, image type 1, this one, it's actually this array that you guys can see in the background. 160, 154, 151, right? That's probably this gray point at the top, you know, so that's probably that point. So again, it's loading all the images and it's turning them into these arrays that we showed in the first notebook when we were explaining how images were composed digitally. So here we have type 2 apples, and pear is type 3, and a green apple is the type 4. So we're loading these images. All right. So step 1 was creating the images and saving them locally. We are then loading them. We're reading the images here. And just as a quick recap, we have 25 images here. We have 26 here. I don't know, seems like we have more red apples than anything else. And we are, so here it's a little bit of kind of creating different classes, and here we need to create the categorical types. There you go. That's more a utility step that we need than something useful. And this is going to be our machine learning model. So we're using Keras, and here I'm going to increase the size of my notebook so you guys can see it with a little bit more detail. We are creating a sequential Keras model. There is also a kind of a functional model. The sequential one is the most common one. And then we're starting to add our layers. Okay, so I don't know if you know what a convolutional neural network is. It's not something we're going to explain in just one workshop. It's a little bit more advanced, but it's just a bunch of images one after the other. And actually, we're going to share a few resources with you, so a few blog posts and free resources you guys can use to understand how convolutional neural net is created. But basically, it's going to be this stack of different layers that it's processing that array of images. And it's going to finally predict the final class of your images. So here we have the input, right? Has the width of the image, the height of the image, and the 3 different colors we have. And the output is 4 different classes. It can be type 1 banana, type 2 red apple, type 3 pear, type 4 green apple. I think that's going to be the 4 different types we have. So we are creating the neural net model, right? This is the function. This is a model, and the summary here is telling you all the, again, the layers that it has. has a convolutional layer, it's kind of a pooling layer, dropout layers, a convolutional layer, another pooling ones. This is the model. And sorry, this should be here. What we're gonna do now is fit the model. The model is gonna be fit with the array of images that were previously scaled, right? Something that I didn't show you in detail was those was one of those steps we had at the top. So we were scaling the images. It's going to work better if we use scaling processing mechanism. And the Y character is the type of the image. So for example, the first image, this one, was a banana. So here it can be out of 4 possible classes, it's going to be banana is going to be 1. Everything else is going to be a 0. This is usually called a dummy variable. I don't know, Tom, if you're still there. We talked about this yesterday. So this is a dummy type of variable. So this is banana is 1, apple and pear, these are all zeros. Right? If you scroll down, here we have our red apple. So red apple is in 1, everything else is a 0. So we're gonna again feed our machine learning model the input, the array, and the different classes. And here we're training different epochs. Actually, I want to turn this thing into something smaller. 20. And now the machine learning model is starting to get trained. Depending on the computer that you have, depending on the number of images you've chosen, depending on the scaling or the resizing you've done in to your images, it might take a little bit more time or a little bit less time. Here we see that the accuracy is improving, and we see the loss, the error, that it's decreasing. Okay, so ideally accuracy is increasing over time, and the loss is decreasing. Okay, so here we're getting approaching 76%, 87%, pretty nice, 98%, pretty nice. Right, so we're probably overfitting this model, doesn't matter. 98%, 1, 95, 96, there you go. So these are machine learning model being trained live. Okay, the loss is also being reduced a ton. There you go. And out of all these iterations, we had 20 iterations. Our machine learning model has a 0.99 accuracy with a 0.013 loss. Okay, this is the error of the model. That's it. So actually, this is something you shouldn't do. We're going to do it anyways for simplicity. But in this case, we're going to try predicting the class of one of these images. I'm going to actually take the image number, let's see, number 5, for example, this one. It's actually, let's use one that looks a little bit better, this one. Number 2 first, and then we're going to use number 5. So I'm going to try classifying, I'm going to try predicting the class of an image, but with the same data that I used for the training process. That's not good. That's something we shouldn't do. But again, for simplicity, I'm just going to go ahead and do it. And let's see what it says. We have completely retrained this process. So this could break right here. This is live. There you go. It predicted a banana. It was, again, from our model. Let's see what happens with the image number 5. There you go. It also predicted a banana. Actually, I can show you guys what a prediction looks like. A prediction is actually an array of the 4 different classes with probabilities, okay, for each one of those classes. In this case, the model is, again, simple and it's kind of overfitted, so it's giving us a perfect accuracy for the banana type. In a more realistic machine learning model, it's going to tell you something like 0.89% probability of this thing being a banana, 0.05 being an apple, you know, stuff like that. And actually, I could try with what is it? Data 1.jpg. Let's see if, I need a target size. Oh, it's good. There we go. So it's predicting that it's a pair. I don't know why, probably of the color. And it's again a little bit overfit, so it's not working so fine. But again, the idea is that it's going to give you a probability of each one of these things being of a different class. So let's try with something different. In this case, we're going to try with an apple. Let's use a different one. I'm going to use, for example, for type 2, we're going to use the first apple. It has a little bit of my shoulder there. So it's going to be the picture at number 0. Red apple. Nice. We're going to use some other one. This one that is deeper. Number 8. Let's see what it says. Also a red apple. Again, we are using the same pictures that we used for, we're trying to predict or classify an image with the same image that we used for the training process. It's not ideal, right? But again, it's just a demonstration. So now it's a moment of truth. I will turn the camera on. We're gonna see what this thing says. All right, so this can break, by the way. Sorry if it does. There you go. So that's my camera right there. Camera. And it has, I don't know why it's changing. The background noise probably affecting it. But let's approach an object here. Red apple, 100%. Live, red apple. There you go. Oh, sorry. I get too excited. Red apple, there you go, it's live. What else? We're gonna put a pair. Let's see what it says with a pair. Not working. A pair needs to be closed, seems. And it's confusing it. So that then, in that case, it's working perfectly. But when I go a little bit deep, it is confusing it with a green apple. So it seems like the shape, when the object is so far away, wasn't taken so accurately. And as we can see, a red apple, green apple, sorry, it's pretty similar. So the machine learning model is having a little bit more trouble defining it. In this case, actually, it's confusing it with a pair. So as you can see, the model is not perfect. Let's see a complicated one, a tough one. What is this thing? Model? What is this thing, model? It's a banana. Nice. Perfect. Are you sure it's a banana model? No, it's a red apple. Nice. So that's our machine learning model that, again, is working live with our fruits. Pear, red apple, green apple. So again, in this case, I'm cheating. I am the one cheating. If I'm approaching it, it's like it took kind of the wrong pattern. What does it say with this red ball? It's an apple? That's what you think? No, you're hungry, machine learning model. You're hungry. It's not an apple. It's a ball. All right. So again, where am I? So my head looks like a pear. There you go. At least I'm not a dog, as it said before. So that is, again, the model working live. Guys, we've trained this model live. We didn't have this plan. I was actually going to use something different, that it's loading the pre-trained model, right? So something you guys can do here, once you're done, is when you have your model, you can, for example, save your weights, right? You can save your weights, all the layers weights on a condensed file. This is a file explicitly used for numeric storage. Or you can save, in this case, you're saving only the weights, the model, where are the model, the layers, they are not saved. You have to reconstruct this thing. Or you can actually save the whole thing. In this case, we can save the whole thing. So model.save, it's going to save the model with the model architecture, all the layers, and all the model weights, plus the state of the optimizer, right? If you want to keep training it later. So this is pretty fun. Okay, you can train, save, right? And make the training process in different stages, right? Or steps. So once you save your model and my model right here is stored locally. It's right here, fruit CNN model. In this case, I have the weights also in case we need to create it. Once you have the model, you can actually import it. So low model with that H5, the summary, it's pulled. So this is a different notebook, okay? This is pulled from my hard drive, just pulling the model. And you can spin, well, in this case, I have to do import. I'm missing a bunch of imports here probably. And time, and it's working. No, NP. Import Numpy adds NP. There you go. Restarting the notebook. There you go. So hopefully we're not missing any more imports. My bad, I changed this thing. There you go. Seems like it's gonna work now. There you go. So the model just loaded, more bananas for the model. Banana, banana, banana. It's actually not doing so well. There you go. Banana. I need to get away. Banana, 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 banana. There you go. So the model again is working. And what I've done is, I killed the process. What I've done is just imported the model from the H5 file. So you guys can train this thing in a supercomputer, and you can then move this thing to a much mundane, regular computer and do predictions with the model already trained. Okay, you can save these, you can store, you can train it in a testing environment, you can move it to production later. This is the beauty of these models that, again, can be saved. You can do the same thing with the sklearn model, by the way. We didn't show it just because it's not necessary. All right, so questions. I have the chat right here. If the model is relying more on the colors and the shape of the info, not so much. It's a really good question. So what you guys will learn when you get into the convolutional neural net world is that actually there is a big difference between based on the different layers that a neural net model has. Usually the first couple of layers are used for what we call as feature extraction, okay? So then is when the model is gonna be kind of, first of all, the pre-processing of your pictures is really important. So you might have a model that relies on grayscale images, all right? So that's gonna be a little bit more interesting in terms of shape, for example, because we're actually getting rid of the colors. So that's step one. Second one is, again, all these first couple of layers that you can actually look at the mobile net model. Where do we have Inception v3? We don't have mobile net, we have Inception v3. So this kernel was working. So model.summary, there you go. Let me decrease the size. So these are all the layers that this model has, a ton. This is the neural net created by Google. I'm still crawling. I don't know if you guys get the update, but this is a crazy model. And what these guys are doing is, again, they have different parts of the neural net. This is why it's called actually deep learning, that are meant for more of the feature extraction part. So some of those layers will be extracting features, and you can actually use those pre-trained models, all right, the feature extraction model for later. It has kind of the optimizer, the classical gradient descent you guys have probably seen already. It's kind of pre-trained. It has found a good spot to keep resuming the training when you feed your own layers. But again, answering your question directly, it's usually really hard to understand how these models are working, because these are deep neural nets. There is no deterministic, there is nothing deterministic behind it. It's actually starting in a random point and it's optimizing from that place. So it's really hard to understand what they are doing. Usually, if you need a little bit more color, if you need a little bit more shape related, or the distance to the camera of to the object, stuff like that, you will need a little bit more pre-processing. Yes, Rory, that's I haven't tried Raspberry Pi, but that's completely possible. Once the model is trained, the predicting phase is really cheap, computationally speaking. It's not really hard, or it's not really process intensive to predict something out of the trained model. That's why I can literally read the model from this H5 file and it can have it predicting instantly, okay? Because the models are, again, those are the important parts. And you can actually, so a mobile phone is not huge in terms of computation powers, and you can guys run this thing also on a mobile phone. And also, something interesting, there is also a JavaScript version of TensorFlow. So you can use the same weights with a JavaScript version of TensorFlow, and you can predict things live, your websites. Okay, this is huge. This is pretty intense. So again, once the model is trained, everything else is simple. Training is expensive.